Now we will look into the third point, which is to determine the volume for storage reservoir or distribution reservoir. So if we remember, why do we need to have distribution reservoir? Because it can provide the gravity factor. Okay, they can provide the gravity factor to the service area. Or what I'm trying to say is the water being sent from the distribution reservoir is through gravity system. Okay, why do we need distribution reservoir or storage reservoir? Basically, the first point or the first reason why we need to have storage reservoir is it will act as a storage for at least 24 to 36 hours. Okay, let's say the water treatment plant has got to shut down their treatment. Okay, so if there is no service reservoir, then the public, whoever live in the uh, township, will not be able to obtain the water. But because of we have a storage reservoir, and the storage reservoir should be designed to cater for 24 to 36 hours of of the flow rate needed at a uh, on that particular township. Okay, let's say one town, let's say town A. Okay, normally it needs 40 million liter per day. Okay, so the storage reservoir should have um, at least that amount. Okay, it should store 40 million liter. Okay, or 60 milliliter because 1.5 days. Okay, 36 hours is 1.5 days. So that means it should have 16 milliliter. So that if any emergency water treatment stops operating, then they can provide water to the service area. And then the water in the storage reservoir also is being used for the fire purposes. Okay, fighting fire purposes. And also is for to equalize supply and demand. Okay, what I mean by supply and demand, if you remember my example in my water distribution system, okay, if the pumping rate is less than the water needed in certain area, so then that is the time for the reservoir to help, okay, to equalize the supply, okay, for the water. And the last thing is that the purpose of distribution reservoir is to maintain constant pressure. Right, we have several types of reservoir. We also have ground surface reservoir. Okay, this is a ground surface reservoir. So you have a circular type and we have a square type. Okay, and this is a fiber reinforced storage reservoir. This is on the land. Okay, so we also have an elevated reservoir. Okay, elevated reservoir is like this. Okay, this is what we call as elevated reservoir. We have a concrete reservoir. We also have a plastic reservoir. Okay, reinforced plastic. And we also have permaglass reservoir and steel reservoir. Okay, so these are all elevated reservoir. So how do we know what is the volume for the reservoir? So this is what we have to learn for today. Okay, these are the activities being carried out in the reservoir. So the uh, water company will sometimes certain duration will check the quality of the water inside the reservoir. So they will be checking the pH, the turbidity of the water, okay, in the service reservoir. And sometimes sometimes they also do cleaning process in the service reservoir. Okay, if you remember, there was a case whereby in service reservoir, okay, we found a dead body in service reservoir in Negeri Sembilan. So because of that, they have to stop. They have to immediately clean this service reservoir. Okay, so sometimes people, we can also find dead people inside of the service reservoir. I don't know how that person can enter the service reservoir. And another story that is happening in Skudai, Johor, whereby some drunken people, okay, was using the water in the service reservoir to take bath. Okay, they were having fun. Okay, taking bath at the service reservoir in Skudai. So they were eventually being caught by the police. Okay, and being brought to the police station. Okay, how do we design that service reservoir? So you should be using mass diagram or hydrograph. So what do we normally do? Okay, so if you look at example here, calculate the distribution storage needed for both equalizing demand and fire reserve. Okay, so calculate the distribution storage needed for both equalizing demand and fire reserve. As you remember, the storage reservoir not only to equalize demand is also needed for fire reserve. Okay, this is on page 73. Okay, the table is on page 73. So I think the question is probably on 72 or 71. Can someone double check with me? What page is it? This question.
72 though.
72. Okay. So hourly, okay, thank you. Hourly demands on the day of maximum water consumption are given in table 1, 73. Okay, fire flows requirement is 63 liters per second for a duration of 3 hours. Okay. Right. We need to know the volume of that storage reservoir. So the volume of storage reservoir, okay, is equal to, all right, so volume of service reservoir is equal to volume for equalizing demand plus volume of fire reserve. Okay, so I think the easiest part is to calculate the volume of fire reserve. Okay, so let's us do that first. Volume of fire reserve. Okay, so storage required to provide the entire fire reserve is equal to the flow rates times the duration. Okay, storage, the flow rate for the fire is 60 liter per second for a duration of 3 hours. So if you can calculate this, 63 liter per second times 3 hours. So this is the flow rate, 63 liter per second times the duration of 3 hours. So you need to times with the conversion factor. Hour and second does not match. That means you have to times certain value, okay, until seconds and hour will be cancelling each other out. And then that value of liter need to be changed into meter cube. Okay. So let's try to do that first. So in that sense, this is 63 liters times 3 hour. So this is the conversion unit, 3,600 seconds per hour. Okay, and divided by 1,000 liter per minute. So you'll be able to find out that the volume is 680.4 meter cube. Okay, so that is the storage reservoir. I'm sorry, the fire demand for the storage reservoir, 680.4 meter cube. So basically, we already got that value, and that is equal to, okay, something that we still don't know, the first part, plus 640 point, which I can remember, 680.4, 680.4 meter cube. Okay, so that is the fire reserve. So we have already got the first part. Okay, so we would like to find out the equalizing demand. So how do we do that? Right, this is where you need this table. Okay, normally in the exam or even in the test, you will be given only these two data. Okay, these two columns of data. So the first column is times, and the second column will be hourly consumption of water in liter per second or meter cube per second. Okay, does not really matter. And only these two columns will be given to you. If it's in your notebooks, okay, if you in your book you can see there are 4 columns, if I'm not mistaken. Okay, but in the real exam or in test, you'll be only given the first 2 columns. So how do we understand this table? Right, we're starting with midnight. This is at 12 o'clock at midnight. Okay, starting we've just started our stopwatch. So the amount of water at that time is only 0.0 liter per second. So at 1 o'clock, okay, the rate of consumption of water is 14.4 liter per second. Okay, so we have to times with 1 hour. So because we would like to know the amount of water in 1 hour. So 14 liter in 1 second. So we know 1 minute, okay, there are 60 seconds. So you have to times 14.4 times 60, okay. And then in 1 hour, there will be 60 minutes. So that means 14.4 times 60 times 60. So we know the amount of water in 1 hour. Okay, and the amount of water in 1 hour is actually 51,000 liters and 840. Yeah, 51,840 liter per that hour. So in your notebook, it says that the volume or the volume is actually 52,000 liters. So they are just round out the number. They are rounding up the number. That's why you got 52,000 liters. But in reality is the value is 51,880. So basically the third column is something that we have to find out ourselves. Okay? Because they have already given you all this data. Let's say that you would like to know the volume being used at from 6 o'clock to 7 o'clock. That means they are using 30.5 liters per second. That means this value has got to times 60 and times 60 to get the real volume being used for that 1 hour, which is 109,800 liter. Okay, so this column also you have to calculate yourself. And for the fourth column, okay, this is the cumulative consumptions. Okay, what do I mean by cumulative? That means we start with 0 at 12 o'clock, and then after 1 hour is 52,000 liter water. That's why the cumulative is 52,000 liter water being used. And then the second hour also they are using 50,000 liter. So you just add up these two values. Okay. So at the end of 24 hours, this is the total of water being used for that particular area. So the fourth column is basically the cumulative volume of water being used at certain area. Okay. So once you have already got all this data, then we need to plot a graph in order for us to find out the volume of equalizing demand. Okay, the volume of this equalizing demand. That's what I mean.